Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this session we'll demonstrate the use of turning within SolidCAM. If we take a look at this part, this is a simple part that has to be turned. And what has to be done on this part is to clean off the face, do the outside contour, work on the inside contour, and besides that, something which we don't see here, we have to add a thread onto the outside and onto the inside of this face. Before I start machining the part, let's take a look at what I've done in my CAM part definition. I've created my home position, which is the center, as you see over here. My material boundary, I've created it by creating a 2D boundary. Now to do that with a 2D boundary, I first have to have a sketch, which I do have, which I've created beforehand. I have a sketch around the part. And my next thing is I must create a clamp. In other words, the actual chuck of the spindle of the lathe itself. Also, again, I must create a sketch around, and this sketch must touch or overlap the material itself, and then I simply define my chain. Another thing that's important is I want to create an envelope around the part on the target and create a target model. I simply click on envelope, click on target model. Then when I define my target, it'll automatically create a sketch around the part according to the actual shape of the part itself. By the way, the view control of a part is simply, together with our CAM views, at the very end we have our CAM turning isometric, and we also have our XZ view. Those are the views that are relevant for turning. And obviously, just as in SolidWorks, I can always go ahead and turn my parts as you see here. Okay, the first thing I'd like to do at this point is to make a rough cut on the outside of this particular part. If I go into my operation that I've created, let's take a look at the geometry itself. The geometry itself goes from here, from this end, all the way to here, and I've created, and this is important to note, I've created an extension to go past my stock material. You'll always see, by the way, the exact stock material that is left for this particular operation. And you can see my stock material, since it's my first operation, is exactly around the part. So I want to start it, and I've created an extension past that stock material, as you see over there. I've also created, just take one more look at this, I've also created an extension past the part also. Next, I'll be choosing a tool, and the tool that I will be using will be an external rough tool, as you can see over here. All the relevant information, the distance over here, the angles, all this information is within the tool itself. My levels area, all I need here is just my safety distance. And in my technology area, I'll be doing the following. First of all, I'll be telling it I'm working as a rough. As you can see, according to the picture here, roughing out the material. Another thing that's important is my process type. I can either work along the part or as a face. In this particular case, the technology that we need to use is along the part. My mode is an external mode. I can work either with or without compensation. I chose not to. And we also have the option of using a machine cycle if there's one available. Again, I choose not to. Now, in my next area, we have our rough and copy field. In this field, we have a control of our downstep. If I have it as constant, then whatever value I have over here, that's the distance. It'll go down every single time. If I choose single, it'll just do it all in one shot. But that's not what I want to do. I want to have constant and to clear off every certain value amount. In my data area, I can tell it how much material do I want to have left for my finished cut. As you see, I can have control distance in X, distance in Z. My connection type could be either smooth or stairs, as you see in the picture. And my direction can be either one way or zigzag. I prefer to use one way. I'll simply say OK. And without doing anything else, I'll go into my save and calculate. And if I do my simulation, let's take a look at my simulation as a turning simulation. I'll make this picture a little smaller so you can understand what's going on. You'll see, first of all, you see over here, this represents the chuck of the machine, and this represents my geometry. And this area here represents the actual stock material left over. Now, if I start going one at a time, you'll see my tool goes down, clears. Next step, whatever it can do up until the point. And notice it always goes past the material. And then it just finishes it off and does as much as it can with the rough cut itself. Now, in my next operation, I'll be doing the face of this part. I'll go into the operation that I've created, and the geometry that I'll be using will be the face itself, making sure I have an extension past this point. Now, if you look at the stock material, you can see now it's showing you what stock material is left over, as I've mentioned before, which is different than it was my first operation, obviously. And I just have to make sure again that my extension at the beginning goes up until this point, and that I'm all the way down to the bottom over there. The tool, I'll be using the exact same tool as I used the last time. And in my technology area, this time instead of long, I'll be using face. Mode, again, external. Compensation, I won't be using compensation or my cycle. I'll be doing the rough cut. And again, I'll be having a downstep of every millimeter, leaving that amount again for my finish. But in this operation, I chose that to continue on and also do a finish cut on my face. Let's just take a quick look at the simulation now. Again, I'll be using the turning simulation, and I'll move it to the middle so we can see it a little better. When I start, you'll note that it automatically shows me what material has to be still has to be taken off. I'm going to be going down now. Notice it goes back to the top, clearing, and we basically have cleared our face of this particular part here. Now in my next operation, I'll be drilling out most of the material that's inside, as you see over here. I'll simply go into my operation that I've created. Note, geometry, there is no real geometry that I have to create, because when I'm drilling during my turning operation, it drills automatically in the middle of the part. The tool that I will be using will be a diameter of 28 millimeters. My levels, same thing as was before. My technology, I have to pick my drill start position, which will be this face, drill end position, which will be the back face, and I can also add something called use chamfer or do not use chamfer. One thing before we continue I'd like to point out is the tool that we'll be using, a drill, is 180 degrees. In other words, we're basically using what we call a U-drill. If I were to do save and calculate and then my simulation, you'll note that the tool will be going in. I'll just use again my turning simulation, and the tool goes down, and as you can see, it's a flat drill tool or a U-drill as we'll be using. Goes straight in and then goes out, and we've created our hole that we need in this part right now. Now in my next operation, I like to finish the outside of this part of here, not including of course the groove itself. If I go into the operation that I've created, again I'll be using the same geometry that I had before in my first operation. The tool, however, will be a little different. Again, it'll be an external tool, but I have a smaller radius on the point over here, making it for a better finish for the tool itself. My technology area, in my work type, I will not be working rough now. I'll be doing what they call profile. And again, long, external, I'll be using what we call our finish option. If I would do my simulation, and this time let's do the solid verify simulation. I'll simply be going with my tool, do it one step at a time, going down, up, clearing off that area over there, going out to the outside, and basically we finished with our outside turning. Of course we still have the groove that we still have to do in our part itself as seen here. In my next operation, I'd like to finish now the inside diameter of the part itself. Note, by the way, that in the inside diameter we also have a groove that we have to deal with later. I'll simply go into the operation I've created, and you'll note that my geometry is from this point here. Let me just take a side view. It's from this point here, and again I have an extension at the beginning up until the very end. Again, I also have an extension at the end. Now the tool that I will be using this time will be an internal tool, as you can see here. And my technology, again, I'll be using the profile option, ISO turning method for finish. And again, if I were to do my simulation, I'll use my solid verify option again. You'll see that my tool will go in. Now, you know, I really can't see what's going on in there. So in my simulation, I can actually see just part of it. I can say I want to see only 3/4 of my toolpath, of my part itself. This way I can see through the part itself. I run the simulation, and I run it again slowly. You'll note the tool goes down, clears, goes across, offsets from the part just to clear out, and then goes out of the part itself. Next operation, I'd like to deal with the groove that we have over here. If I go into my operation, I chose to use a grooving operation. My geometry, as you can see over here, is simply this groove over here. Again, extending it at the beginning and extending it at the end past the material that I have left over. The tool I'll be using a tool which is specifically meant for grooving, with all the relevant information that we need put in over here itself. Now, in my technology area, my working type, I'll be using a rough cut. I'll be working along the face and external. But I'll be using what we call finish turn groove method. Now, before I continue, let's go back into my work type rough, and I'll go into my data area. Let's take a look at what I have here. I have my offset type, clearance distance, my step, and my step over. If I want to go from side to side and then go down, or from the middle to the outside, as you see over here. Side to side, or from middle to the outside. And I chose from one side to the next. I have my finish turn groove method, and let's take a look exactly what's going to be happening over here. If I had to do my simulation, and this time I'll use my turning simulation. My first step, you see my tool will come down, and you see it's pecking its way down all the way to the bottom, goes up, working what we call side by side, from one side to the next side, as you see the tool going down. Now it's going to go down, do a finish cut from one side to the next, and we basically finish working on the groove, on the outside groove of this part. Now, in my next operation, I'd like to now finally deal with the groove that we have inside the part itself. What I'll be doing here is simply going in. My geometry will be at the inside of the part itself with my extensions, as you can see over here. The tool that I will be using will be a specific tool specifically for internal grooving. The tool itself looks like this. My technology area, since I am working a grooving operation, I'm working again long, but I'm working this time internal. Again, I have in my data area the amount of material I want to have left over if I want to work from side to side. And again, my finish, I'll be using the turn groove method. If I were to do again my simulation, and again I'll show you my simulation in my turning method, you'll note as I go down, tool goes in, exactly the way you did my outside, and then it'll finish off the part itself. In my next operation, I've decided that I need to have a thread on this particular outside diameter. So what I've done here is as follows. I've used the option of a threading operation. My geometry is the actual top outside boundary of my thread. Again, extension at the beginning and extension at the end. The tool that I will be using is an actual external threaded tool. And in my technology, again, I'll be working along. I'm doing an external thread. And I want to have finishes on the corners itself, on the threads itself. And my working type will be multiple. In other words, not one pass, but several passes until I finish down to the bottom. Over here I describe the pitch unit I'll be using, whether it be in millimeters or thread per inch, and my step down, how much I want to go down every single time. And what's important here is my minimum diameter. What's this final diameter I want my thread to go to? If I were to do my simulation, and again I'll be using my turning simulation, you'll see that my tool goes down, starts working its way in, until it finally gets down to the bottom. I'll slow it down, let it run all the way through. At the end, we have our thread on the outside. Let's just take a quick look at my solid verify option. Again, my tool is going down, going across the part until it finishes the entire thread on the outside, as you can see here. Next, what I'd like to do, I'd like to also create a thread on this inside face over here. Again, I'll be using my threading option, my thread operation. My geometry this time is this line over here, only up until that point with an extension. Also, again, an extension at the beginning. The tool, this time I'll be using a specific tool meant for internal threading. And my technology, this time I'll be using my mode as an internal mode. Again, we have the same options that we have over here before, but this time I'll be telling it my maximum diameter. What's the maximum diameter I want the tool to go to? If I were to take a look at my simulation now, and again, I will use the option of my turning simulation. The tool will go down and create the thread inside, as you see over there. My next and last operation, I'd like to cut this off from the stock that's on the machine itself. So what I've done here is, again, I've used a grooving operation. My geometry, if I were to show, is this area over here. Again, extension at the beginning and extension at the end. The tool, again, will be an external groove tool, always making sure that the length over here, my C length, is big enough to cover that entire area. In my technology, this time I'll begin using a long, but I'll be using my work type as cut, as to cut the end off over here in my grooving operation. Now, what's important over here is the fact that I can also, if I want, add a chamfer to the corners as I'm cutting off the part. I can say I have a chamfer on the right side of 45 degrees of 0.2 millimeters. Let's just take a quick look at my simulation. I'll use my turning simulation, and let's just take a look at it the way it is right now. My tool will come in, start working its way down, and as you see, it has created a chamfer in this corner. I'll let it finish. I'm going to zoom in on this area over here, and we'll take another look at it again. As you see, the tool goes down, now it goes back up, creates the chamfer, and then continues going down until it finishes cutting off the entire part itself. Let's take a look at this also in our solid verify simulation. You'll see that the tool will be coming down, putting a chamfer on, and cutting off the entire part. If I don't want to see this, I can simply get rid of my fixture, my chuck. I can see this. If I don't want this excess material here, I can simply go into my split machine and only look at what I need to look at. Only solid 2, which is this part here. As you see, this is my finished machined part. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.